All right, today we're going to be solving radical equations again. But today specifically we're going to look at things where my variable or a quantity my variable is inside of has a fraction exponent on it. So irrational exponents, which remember are related to radicals. So in fact, in our first step today, if necessary, we're going to rewrite any radicals as rational exponents. So if I have, say, the square root of x, I might replace that with x to the 1/2 power. Or if we have a quantity, let's say the square root of x plus 1. In fact, let's say if I have a quantity like the cubed root of x plus 4, we could write that as the quantity x plus 4 to the 1/3 power. Okay, so if we have a radical, or x is inside of a radical today, we're going to write them as their fraction exponent forms. Okay? Step 2 is to isolate the variable or quantity with our rational exponent acting upon the variable. So, well, that's a lot of words there, but basically, if I have a quantity like this in number 1, we need to get that quantity by itself. So, some things we need to get rid of here as we'll work along and do number 1 is we need to get rid of this 1 held with addition and this 4 held with multiplication. So the first thing to get rid of is that 1. Let's go ahead and subtract our 1 over. Remember, get rid of things with addition or subtraction first. Always. So this is to the 2/3 equals 16. Okay, next up, we need to get rid of that 4 in front. And no, you cannot distribute it in. Think of it as when we have this exponent here, everything inside of here is like in lockdown. Okay, nothing comes in or out until we eventually get rid of that exponent. But we can deal with that 4 by dividing both sides by 4. And these 4's on the outside will cancel each other out. And we have the quantity x plus 5 to the 2/3 power equals 4. Okay, so we've now isolated it. We've done step 2. Step 3, raise both sides of the equation to the reciprocal power. So remember, reciprocal is like if I have the fraction, say like we have in our problem 2/3, the reciprocal just means to flip it upside down. So what we're going to do is raise both sides of the equation here. And since there's already parentheses, I'm going to use brackets just to distinguish them. But you could use parentheses again if you'd like. And we need to raise both sides to the reciprocal, which would be 3/2 power. And it does have to be everything on both sides. Okay, what's going to happen here? Remember, properties of exponents. When I raise a power to a power, we multiply the exponents. And if you were to multiply these top times top, bottom times bottom, we're going to get an exponent of 6/6, which is equal to 1. So essentially, these are going to reduce to x plus 5 to the first power, which is just x plus 5. We've essentially gotten rid of our exponent. And now our x plus 5 is out of its radical prism. However, on this side, we do need to evaluate what is 4 to the 3/2 power. Well, remember, the denominator tells us the root, so this is a square root of 4 raised to the 3rd power. Well, we know what the square root of 4 is. That's 2. And 2 cubed is 8. So finishing doing a bunch of work on the right-hand side, we now got an x plus 5 is equal to 8. Okay, so now, of course, it says finish solving for the variable. We're kind of in the middle of doing that. We would need to subtract 5 to finish getting x by itself here. And 8 minus 5 is 3. We end up with x equals 3. The only thing left to do is check. Now you can check this by hand, of course, which I'm going to do for this problem, where I have x, I'm plugging in 3 plus 5 to the 2/3 plus 1. Does this equal 17 is the question we're trying to find out. So 3 plus 5 in the parentheses becomes 8. So remember, we're following order of operations, so we've simplified in the parentheses. Now we would do our exponent. This is the 3rd root of 8 squared. So evaluating that, the cubed root of 8 is 2. And 2 squared is 4. So this becomes 4 times 4 plus 1, which gives me 16 plus 1. And the left does end up equaling 17. I haven't done any work on the right. And yep, 17 does equal 17. You're also welcome to use a calculator, like say Desmos or something, and just plug 3 in there where we see x, right? Substitute it in, calculate all of this on the left, and see if we do get our matching 17. Okay, let's do a few more examples. So I've written the steps here again. So example 2, this time, my variable, it's not a quantity, it's just the variable. And please keep in mind, 4/3 is not acting on 2, right? If it needed to act on both, they would have needed to put parentheses there. So this is only acting on the variable x. And so that's what we need to isolate. So first thing, once again, get rid of things with addition or subtraction. So let's add 3 over, okay, which ends up giving me 2x to the 4/3 power equals 162. Next, we need to get rid of that 2. So let's divide both sides by 2. Now we've gotten our variable with our fraction exponent isolated. And here's where we need to raise both sides. We're now in step 3 here above, to the reciprocal power. So don't forget to do the reciprocal here. So we need to raise both sides to the 3/4 power. And again, the reason that reciprocal is necessary is when we raise our power to a power and we multiply these, we're going to get 12 over 12, which reduces to 1. So we get x to the first power, which is just x, equals 81 to the 3/4. So remember, again, I need to calculate this out. The bottom number tells us what root. This is the 4th root of 81 cubed. And you can double check this, but the 4th root of 81 is 3. So we get x equals 3 cubed, and 3 times 3 times 3 is 27. X equals 27. So now, of course, we should check our work to make sure that this is a valid answer. So we plug in 2 times 27 to the 4/3 power minus 3. Does that equal 159? So here, there's no simplifying in the parentheses. We go straight to exponent. And remember, that means the 3rd root of 27, which evaluates to 3, raised to the 4th power. Okay, so now I need to do 3 to the 4th power, which ends up being 81. 3 times 3 times 3 times 3. 2 times 81 is 162. So multiply and then add or subtract last. And 162 minus 3 is 159. So it does work out, makes our equation true. 27 is the final answer for example 2. Okay, example 3 takes us back to like we had last time where we had radicals. Remember last time we said get the radical by itself and then raise both sides to that power. We'd raise both sides to the 3rd power. So let's see how that still works with our new rule. We said, if necessary, rewrite anything with a radical as a fraction exponent. So we could write this, x minus 6 to the 1/3 power. Okay, so that was step 1, rewriting this radical as x minus 6 to the 1/3. So just like before, let's get this radical by itself. So we're going to subtract 4 over. We get x minus 6 to the 1/3 power equals -2. Now last time we said to identify n and raise both sides to the nth power. Okay, so we would have raised both sides to the 3rd power. So here, remember, if we're raising both sides to the reciprocal power, that would be 3 over 1, which is really the 3rd power. It's the same thing we would have done before, but we're following our new rule, which will apply to both radicals and fraction exponents. So again here, if we were to multiply these together, we'd get 3 over 3. We've reduced this exponent to a 1. And x minus 6 to the 1st is just x minus 6. It's free from its radical prison. However, over here, we do need to evaluate this. 3 to the 1st power really is just 3, so we don't have to think about taking the 1st root, which is just itself. But we do need to do -2 times itself 3 times. And be careful, if you're plugging in a calculator, you need to put these parentheses around your -2. Okay, the answer we get is -8. Okay, if you happen to put it in the wrong way in your calculator for this problem, you will get a correct answer. Okay, for other problems you may not, so be careful. Lastly here, add our 6 over, and we end up with x equaling -2. But remember, we have to check our work. So I'm going to come back to the original problem. The cubed root of -2 minus 6. Put my parentheses for substituting in there. It's a parenthesis. Plus 4, does this equal 2? -2 minus 6 is -8. The cube root of -8 is -2. And -2 plus 4 is 2. Yep, 2 equals 2. It looks like we did get a valid solution. But remember, sometimes you get extraneous solutions or ones that didn't work like we saw last time. So yes, you do need to continue checking. Okay, let's do one more. Our last one here, I know it looks a little bit simpler, but notice they've thrown in a negative fraction exponent. So one more element that we've already looked at before. So here, our variable with our fraction exponent is already isolated. So we didn't have to write it as a fraction exponent. That was already done. It's already isolated. And so we're still going to raise both sides to the reciprocal power. The reciprocal of -2/3 is -3/2. So we need to raise both sides to this negative fraction reciprocal. Now here though, remember, a negative times a negative is positive, and we're going to get 6 over 6. We've gotten rid of essentially of all of our exponents and turned it into a positive 1. X to the first is just x. Okay, the rest of the difficulty in this problem is just going to be to evaluate this. So one thing to remember, if you were to apply a negative exponent over division, which we can distribute this, I get 1 to the -3/2 and 25 to the -3/2. Now remember, with a negative exponent, to make it positive, you change its place in the fraction. So that's going to come down, become 1 to the +3/2. This 25 is going to end up going up top and becoming 25 to the +3/2. So when you're raising a side to a negative exponent, we end up getting the reciprocal of our fraction. Right? 25 ends up on top, 1 ends up on bottom, and then we need to raise each of those to this fraction power. So remember, this tells us the root. We're taking the second root or square root of 25, and the number up top tells us the power, and cube it. Okay, same thing in the bottom. Really, the square root of 1, and you probably won't need to repeat this after I do it, cubed. Well, the square root of 25 is 5. And 5 cubed ends up being 125 up top. Down below, the square root of 1 is 1. And 1 cubed, 1 times 1 times 1 is 1. So we end up with, essentially, x equals 125. Okay, now we just need to check it, of course. This will be a little easier to check. 125 to the -2/3 power. Does that equal 1/25? Well, let's see. Plugging in now, I have to work backwards with negative exponents here in my check. To make this thing have a positive exponent, we're going to bring it down. This becomes 1 over 125 to the +2/3. Okay, remember over here, this means we're taking the third root down here in the bottom, the cubed root of 125, and squaring it. Well, the cubed root of 125 is 5. And 5 squared is 25. And sure enough, we do get 1/25, equals 1/25. Another one passed our check. We got pretty lucky in these 4 examples. Of course, we'll try some more in class, but they all passed our check. Please make sure you're checking even if you're using a calculator.